Hello Algebros, this is the last installment of Are the expressions equivalent or are the scenarios equivalent? So we're just elevating it a little bit on this video, and I'm going to be moving back and forth because I don't have quite enough room where they give me to write. So I'm going to do the odd problems on this one, leaving you with the even problems to do for your assignment. So if we take a look here at number 1, we have 5x plus 3 plus 3x squared minus 2, and we're seeing if it is equivalent to 5x plus 1 plus 3x squared. So we can't tell right off the bat, we need to simplify both sides. There's nothing to multiply on the outside of these parentheses, so that just tells me I need to go straight into combining like terms. I don't have any other squared terms, so I'm going to write 3x squared, and then I go down to my x term. 5x is the only x that I have, so plus 5x, and I do have two constants here. 3 plus a negative 2 would give me a positive 1. So when I go to simplify this, I want to write it in standard form just like I did over here. So I want to write my x squared term first, and I have 3x squared, positive 5x, and a positive 1. And I go to look, 3x squared plus 5x plus 1 plus 1. Yes, they are equivalent expressions. Oh, I don't know what happened. Okay. All right, let's take a look at number 3. So number 3, we have 2x plus 1, and that is squared, minus 2x times the quantity of x minus 3. And we want to see if it is equivalent to 6x squared plus 6x plus 2 minus the quantity of 2x minus 1 squared. Right, so if you have forgotten how to square a binomial, this is going to be a great opportunity to get a reminder of that. So I'm going to go ahead and write it all out. So we know that exponents tell us that it's repetitive multiplication. Well, in this case, the whole expression is being raised to that power of 2, so it's the whole expression times the whole expression. So we have 2x plus 1 times 2x plus 1, and we're going to, I don't know if you've ever heard of FOIL, first, outside, inside, and last. So we're going to take the first terms in both sets of parentheses and multiply them. 2x times 2x would be 4x squared. Take the outside term, so the bread to the peanut butter and jelly, if you will. 2x times 1 would be 2x. And then the inside, so the peanut butter and jelly, the inside pieces, 1 times 2x, which would be 2x. And then the last one, so the last values in the parentheses, 1 times 1 would be positive 1. And then we still have that negative 2x times the quantity of x minus 3, so we need to distribute that as well. So we have a lot of multiplication going on in this next step. Negative 2x times x would be negative 2x squared, and negative 2x times negative 3 would be positive 6x. All right, so now we can combine our like terms. I have 4x squared minus 2x squared, which gives me 2x squared. I have 2x plus 2x plus 6x. So 2x plus 2x would be 4x plus 6x would be 10x. And if you're confused about that, I have 2 apples, my friend has 2 apples, and we go buy 6 apples at the store. Together we're going to have 10 apples. So that's how you combine your like terms. And then the only constant I have is 1, so plus 1 goes at the end. So my left side is fully simplified. Now I've got to do that again to the right side. And I have this again. So you can see it one more time. Oh no, I don't want to do that. Okay, we'll just go with it. Okay, so we're going to do that first outside inside last again. So first numbers in the parentheses, 2x times 2x would be 4x squared. The outside, so the bread to our peanut butter and jelly, 2x times -1 would be -2x. The inside, so the peanut butter and jelly, -1 times 2x would be -2x. And the last piece is, so -1 times -1 would be +1. Right. Don't forget that we had that negative sign out front, so that changes a little bit of. So I have 6x squared plus 6x plus 2, and then I'm going to distribute that negative throughout. So I have 6x squared plus 6x plus 2 minus 4x squared. I'm going to go ahead and combine those. That'd be -4x times negative, so that'd be +4x, and then negative times that 1 would be -1. Combine my like terms. I have 6x minus 4x squared, which would be 2x squared, 6x plus 4x, which would be 10x, and 2 minus 1, which would be +1. So as you can see here, 2x squared plus 10x plus 1 equals 2x squared plus 10x plus 1. So those are equivalent. There's a lot going on. All right, let's, I would encourage you to pause that and write that down. Hindsight. Okay, and let's take a look at the very last one. Number 5. We have 6x times the quantity of x plus 1 and 6x squared plus 6. So I'm going to distribute that. So 6x times x would be 6x squared, and then 6x times 1 would be +6x. And then what I have on the right hand side can't be simplified, or it already is simplified. And 6x squared plus 6x does not equal 6x squared plus 6. If there was an x on that 6, then they'd be equivalent, or if there was not an x here, then they would be equivalent. But since there's an x on that 6 and not on that one, they are not equivalent expressions. All right, some of the support videos that I will have listed today will be multiplying binomials together. If you want a little bit more in-depth instruction on that, that's something that you should have gotten in Algebra 1, so it might take a little bit of time to kind of oil up those gears and get that back to being efficient like it used to be. So the additional support videos will focus on that. All right, well, happy mathing. I will see you guys later.